Hello students. Today, we are going to understand the concept of time of ascent, denoted as TA. The time of ascent is the time taken by the projectile to reach its maximum height, where its vertical velocity becomes zero. Now, let's look at the proof. We use the kinematic equation, Vy equals Uy plus Ay times t. At the maximum height, the final vertical velocity, Vy, is equal to 0. The initial vertical velocity, Uy, is equal to V0 sine theta. The acceleration due to gravity, Ay, is equal to negative g. And finally, the time taken, t, is equal to Ta. If you look at our diagram, we have plotted the trajectory of a projectile on an xy coordinate system. The horizontal axis is the x-axis, and the vertical axis is the y-axis. The projectile starts at the origin 0, 0 with an initial velocity of v0. Let's break down the velocity into its components at different points along the path. Because there is no acceleration in the horizontal direction, ignoring air resistance, the horizontal velocity, Vx, remains constant throughout the entire flight. You can see this labeled on the diagram. We define this initial horizontal component as Vx is equal to V0 cos theta. Now, let's look at the vertical component, Vy. Initially, at the start, the vertical velocity is Vy is equal to V0 sin theta. This component is positive as the projectile moves upwards. At the very top of the arc, the projectile momentarily stops moving upwards, so the vertical velocity, Vy, becomes 0. As the projectile descends on the right side, the vertical velocity, Vy, becomes negative, indicating it is moving downwards. Finally, let's look at the position of the projectile at any specific time t. Its location is defined by the coordinates x, y. The horizontal distance it has traveled from the origin is x, and its vertical height above the ground is y. Understanding these components is key to solving all projectile motion problems. Let's derive the formula for the time of ascent, Ta. This is the time it takes for a projectile to reach its maximum height. We start with the fundamental kinematic equation for vertical velocity. Vy equals Uy plus Ay times t. Now, we apply the conditions at the maximum height. We know two crucial things. At the peak, the final vertical velocity, Vy, is 0. The initial vertical velocity, Uy, is given by V0 sine theta. The vertical acceleration, Ay, is due to gravity, so it's negative g. The time taken to reach this point is Ta. Substituting these values into our first equation, we get 0 equals V0 sine theta minus gta. Next, to isolate the term with time, we move the negative term to the left side of the equation. Gta equals V0 sine theta. Finally, to solve for the time of ascent, Ta, we divide both sides by g. This gives us our final formula. Ta equals V0 sine theta divided by g. That concludes our lesson for today. Thank you for watching. This content is brought to you by the Ekalavya Educational Channel. Remember to keep learning and keep growing. If you found this helpful, please support our channel by liking, sharing, and subscribing.